Okay, on the en route segment, Tony, you got me all the way to a place called Paradise. Now we're leaving Paradise for a place called Damps. What happens next?
You're right, Jack. We're on a radar vector. We can expect a radar vector from the Paradise VOR to intercept Victor 23 near the Damps intersection. And we're now within range and we can begin preparing for the approach into Palomar. Now, incidentally, Jack, in this briefing for the approach, we're going to cover such things as the approach chart, the area chart, the radar vectors, the approach segments, aircraft speed and performance chart, the use of the autopilot on the approach, and the pilot controller responsibilities. Incidentally, these pilot controller responsibilities are quite important to understand by both the controller and the pilot, and you can find that, section in the AIM. It'd be a good idea to review that. Now, when we're within range, the first thing we should do is copy the ATIS information. And I suggest you copy that right on your flight log so that it'll be available to you. And then set your altimeter to the local altimeter setting. The next thing, probably the best thing to do, would be to fly the approach mentally.
Now wait, I want to show off here just a minute. You told me before that if there was an altimeter correction, that was the time to apply it. See, I remember those things, Tony.
That's correct. If on the departure from Denver you had an altimeter correction of, say, 0.04, then every time you get an altimeter setting, apply that correction factor, a plus 0.04. If you'll find if you're making a precision approach, it'll be much more accurate that way.
Good.
Now, it's a good idea to highlight certain information on the approach plate, whatever information you think you might want to refer to during the approach. You see, you should not study this approach plate during the approach, but it is sometimes necessary to get pieces of information. Now, you should study the approach plate during the briefing or the pre-flight planning, such as we're doing now. However, sometimes when you get the ATIS, you find there's a different approach in use, or especially if you have to go to another airport, then you have to get the plate out after you learn from ATIS what approach is in use. Now you have to get the plate out and study it. But try to mentally fly that approach as far out as you can so there won't be any surprises during the actual approach. Now, as I said, no two people probably will highlight the same items on the approach plate. Just take your highlighter and highlight whatever you think is important to you. And then we can begin setting up the navs for the approach. Jack, would you review the identification feature of the navs?
Yeah, you told me to make sure that I hear the ident twice, and that normally the VOR ident comes on about 8 or 9 times a minute, and so I should listen for at least 2 of those. If I hear just one and then 30 seconds later hear another one, it may be that the VOR is down, but the DME is still operative, and so I can't use that facility. Does that happen often?
No, it doesn't happen often, but if it did happen during when you were trying to make an approach down to minimums, it could be a very important time.
Well, wouldn't it be in the NOTAMs that I checked?
Not necessarily. It might be an unscheduled maintenance period.
Okay.
And if that should happen, you can check it right away, and they're monitoring these facilities, and the monitor will tell whether it's usable or not.
All right.
Now, there's another way of identifying these facilities, Jack. For instance, if you hear Denver VOR. Well, that's as good as a coded signal. But if you're listening to a voice transmission giving weather and other information, that does not mean that necessarily the VOR is usable. Listen in that case for the coded signal. It may not be there, in which case it is not usable. Now, Jack, the Jeppesen approach plates are divided into 4 sections: the heading, the plan view, the profile, and the minima section. Now, at this time, we'll just cover these sections just briefly, and I'll give you a more thorough briefing on all of the charts, including the NOS charts, in a later briefing which will include all of the non-precision approaches. Notice the airport elevation at Palomar is 328 feet. This represents the highest usable portion of the airport. Now, the minimum sector altitude circle that we see here has a 25 nautical mile radius, and it is based on a primary facility that will be used during the approach. That facility is always identified just to the right of the circle. Now, these circles may be different for different approaches to the same airport. For instance, the VOR approach at Palomar has a different circle, a minimum sector altitude circle, than the ILS approach does. Remember, too, that the altitudes you see in the minimum sector altitude circle are emergency altitudes only. You shouldn't plan on flying them. They do, however, guarantee 1,000 foot clearance above all terrain and obstacles within that segment. However, remember, in mountainous territory, 2,000 feet is required.
I'd want at least that, yeah.
Also, a navigable signal is not guaranteed at these altitudes. Now, if we take a look at the comm box, the first thing we see, or one of the things we see up here, is a small R in the communications box.
Now, why are these listed this way?
These are listed in the order in which they are commonly used, and that's helpful.
Okay. Now they are. I just didn't know why they were that way.
Okay. Small r means radar is available, so you can expect radar vectors for an approach to Palomar. And that'll become important a little bit later on. Also notice the small asterisk that we find opposite some of the facilities. That means that those facilities are not continuously in use. So therefore, maybe the note at the bottom would have some bearing on that. The note here says when the control zone is not effective, and that means when the tower is not operational, that we must use the Miramar altimeter setting. Now, that should ring a little bell here, raise a red flag, so let's go down and see what the minimums are. 523 feet when the control zone is effective, but we have a little note, a number 1 here. Over in the explanation, the number 1 says that when the Miramar altimeter setting is being used, the minima is raised by 80 feet to 603 feet. You see, when a remote altimeter source is used, the obstacle clearance in the final approach and circling areas is raised by 5 feet for each mile in excess of the first 5 miles. Now, Jack, notice the plan view on the chart is drawn to scale, and the scale is noted here on the left side. In this case, 1 inch equals 7.5 nautical miles.
Now, is that standard?
Well, more likely you will see 1 inch equals 5 miles, but when they have to get more information on the chart, they'll use a different scale. These are the only 2 scales you'll find. 1 inch equals 7.5 or 5 miles.
Okay.
Now, another thing that we can note from this chart is that this ILS is a little different than most in that the NDB is not co-located with the outer marker, so it is not called an LOM, or locator outer marker. Another thing that you should remember is that when you're looking at the minima, you're flying a Baron, and that's a Category B aircraft. That means that you would be making circling approaches somewhere between 91 and 121 knots normally. After we leave the Oceanside VOR, we will be on a segment of the approach. And a segment of the approach has to meet certain requirements. For instance, it has to have designated on it an altitude, a direction, and a distance. And JEPS helps out a little bit here by making all segments of the approach heavy, thick lines with a broad arrowhead.
Okay, but this one has both a heavy line and a light line.
Yes, you see there are other light lines on the chart, and those light lines don't have all those requirements, don't meet all those requirements, and they merely designate points such as intersections. Sometimes there are combinations, such as with the initial segment here. The light line indicates where Homley intersection is on the 083 radial at 18.3 DME. But since it also has the heavy line and meets all the requirements, it is a flyable route. Now, when the initial fix is not a part of the en route structure, it may be necessary to designate additional routes for the aircraft to proceed from the en route structure to the initial approach fix. There may be several initial approach fixes for an ILS approach, and therefore several initial approach segments. For instance, at Palomar, there are 2. There's the initial approach fix at Oceanside and the one at Julian. If an intermediate fix is part of the en route structure, as that is, it's on an airway, then the initial segment may not be designated, in which case the approach begins at the intermediate fix. An intermediate segment is very important to every IFR pilot. It's your last chance to configure your aircraft and get it positioned and at the proper speed for the approach. try to make that intermediate approach, segment of the approach, at least 2 minutes or 4 miles long.
Okay.
An ILS approach segment begins, the ILS intermediate approach segment begins at a point where the initial approach course intercepts the localizer course. It extends inbound to the glide slope intercept point where the final segment begins. Now the final segment begins where the glide slope is intercepted and extends to the authorized decision height. The final segment must be aligned with the center line of the runway. The missed approach segment begins at the decision height and ends at an appropriate point or fix where en route obstacle clearance is provided. Now, more detailed information dealing with these segments of the non-precision approaches will be dealt with in our briefing on the non-precision approaches, which we'll get into sometime later.
Now let me go over these 5 types of segments again. There's the feeder segment, the initial segment, the intermediate segment, final segment, and the missed approach.
That's correct.
Now, not all approaches will have all 5, but those are the 5 possible.
That's true.
Okay.
And so many times the pilot will plan to fly all of those segments except the missed approach segment. Then if he has to make the missed approach, he's kind of lost for a little while. So plan to fly all of them on every approach. Then if you don't have to make the missed approach, hey, that's great.
Good. Okay.
Remember too, Jack, that a DME arc is an initial approach segment, as with a radar vector. That's also an initial approach segment.
Okay.
Now, Jack, the profile view is not drawn to scale. And the heavy line that we see here is both for the precision approach and the non-precision approach, at least to the point where it intercepts the glide slope. Then the dashed line that you see represents the non-precision approach, or the localizer only approach. This chart indicates that we must cross the NDB beacon at Escondido no lower than 3,400 feet. All of the altitudes you see on these charts are minimum altitudes. If we're at 3,400 feet at Escondido, we will be 3,077 feet above the touchdown zone. Now, the altitudes that you see in the parentheses are altitudes above the touchdown zone, not above the ground. As a matter of fact, at the Escondido beacon, we could be as close as 1,000 feet.
That's because those hills coming up from the ocean there, I imagine.
Well, that and the fact that in the intermediate segment, you're only guaranteed 1,000 feet above terrain.
Okay.
Now, I'm sorry, in the initial segment.
All right.
On the intermediate segment, you're guaranteed 500 feet clearance above terrain. Now, you'll cross the outer marker at 2,106 feet if you're right on the glide slope and your altimeter setting is correct. So if you're on the glide slope and you're more than 100 feet off of 2,106 feet, ask for an altimeter setting. As a matter of fact, it's a good idea to ask for an altimeter setting as you pick up the tower anyway, as you go over to the tower.
Mm-hmm.
Now here's something interesting, Jack. Many times the marker beacon will fail for some strange reason. It just won't work, and you can't accurately check it in flight. All you can check is the circuitry. However, if they ask you to report the outer marker as you're coming through 2,106 feet, report the outer marker if you're on glide slope. It's that accurate. You know, Jack, many instrument pilots have a problem on the final, and they're jockeying the power back and forth, and the airspeed is wandering back and forth.
I'm one of them.
And they never get settled down during the entire approach. Well, here's something that can help you with that. It'll help you get settled down. It's called an approach speed chart, and you can develop one for your own aircraft. As a matter of fact, this chart is for a B-55 Baron. And you'll notice that when you're on the feeder segment, and many times the controller will ask you to keep your speed up. Well, remember that in controlled airspace such as TCAs, the maximum speed is 157 knots. Well, we can give him 160, that wouldn't be too bad. And your Baron will do 160 at these lower altitudes with 2,200 RPM and 21 inches of mercury clean.
Mm-hmm.
Now, of course, at some point we're going to have to slow the aircraft down and get configured for the approach. And that's a judgment call. In some cases, you'd want to do it as you're approaching the initial approach fix. In the case that we're talking about here at Palomar, you'd probably want to fly out the initial approach fix for several miles before you slow down. When you do decide to slow down to the approach speed, and 120 is a pretty good approach speed for most light twins, 120 knots on the final. Reduce the manifold pressure to 17 inches and drop approach flaps. The aircraft will stabilize at 120. We'll fly the approach all the way down to the point where we intercept the localizer, and we're inbound all at 120, same configuration, until the glide slope centers. At that point, we just drop the gear. Just the mere dropping of the gear will give us about 500 to 600 feet per minute rate of descent, and the airspeed will stay very close to the 120. We probably wouldn't have to touch the power at all. However, since we're trying to maintain a glide slope, and there are some variables here such as headwinds, tailwinds, updrafts, we may have to use the power to stay on the glide slope and keep the airspeed at 120. So the way to do that is to use the elevators to stay on the glide slope so long as the airspeed stays within 5 knots of our target airspeed of 120. Now if it gets too fast, above 125, or too slow, below 115, then just reach over and adjust the power, but don't look at the manifold pressure. Keep your eyes on the flight instruments and adjust the power for effect. Now, as we're coming down the glide slope then, someplace between the outer marker and the middle marker, perform a gump check at your leisure. Then the next thing we're going to do is either see the airport or cross the middle marker. So don't put full flaps down until you definitely have the airport in sight and the landing is assured. Then plan on slowing down from 120 to a transitory speed of 95 as you cross the runway threshold at the target altitude, in this case about 40 feet, and flare to a touchdown on the runway. Now try to do this the same way every time, whether the landing is IFR or VFR, and you'll find your approaches and landings will work out much better for you. But this is a must for a stable instrument approach, and we'll practice this on subsequent approaches.
I look forward to it because speed control on that ILS is difficult for me. I'm
Yes.
always chasing it seems.
Well, you should figure out various configurations and power settings and know what the expected result will be. Remember that a given configuration and power setting will result in a predictable performance. That'll be very important to you as well on single engine.
Well, fine. Thank you.
Now, we were assuming that we were on Victor 23, and now let's say we're approaching Oceanside, and we've been turned over to San Diego approach. Now let's take a look at the area chart.
Okay.
They've changed these area charts recently, and they're much more usable than they used to be. Remember some time ago I said that when you were on radar vectors, to keep track of where you are, because radar controllers have flown aircraft into the terrain, and you must guard against that constantly. So don't give up keeping track of where you are because you're on a radar vector.
Does that happen out in California?
It happens everywhere, but maybe California more than other places because of the high terrain that's prevalent out there. Notice that they have chosen a centralized VOR, and they've struck radials here every 30 degrees and labeled them, and arcs every 10 miles and labeled those. So with your DME and your VOR, you can see what segment you're in and follow your progress constantly here. The other thing you want to watch out for is altitude. We're still on an area chart, not on a segment of the approach, so don't go below the MEAs on the area chart. Remember the rule of 1, 2, 3. If you're cleared for the approach from a far distance out, don't descend below the MEAs on the area chart or the en route, whichever you happen to be on, until you're within the safe sector altitude, the minimum sector altitude circle. And even there, don't go down to those altitudes because they're not generally not flyable altitudes, but we do know they offer protection. So the next thing then would be, number 3 would be the route segment itself. When you're on a route segment, then you can follow that all the way to the ground. Notice that we have shaded areas on the area chart. And inside of those shaded areas are altitudes. If the figure inside the shaded area is less than 7,000 feet, you can fly over that area at the altitude indicated and be guaranteed 1,000-foot clearance over all obstructions in that shaded area.
Here's one at 86.
If it's over 7,000 feet, it's mountainous terrain, and if you fly over that area at 86, you're guaranteed 2,000 feet clearance over everything in that particular area. Notice the large amount of white area, and you'll find this on all area charts. Somewhere on the chart, usually down the lower left-hand corner, is an explanation. And here it says that the highest area minimum altitude, or AMA, outside of the shaded areas, or in the white areas, is 3,000 feet. Remember, at Denver, the white area was 9,000 feet. So be familiar with this chart and make use of it. It tells you one other thing, too. We have a TCA down here at San Diego, and this scalloped area outlines the TCA. However, go to the TCA chart in the JEPS book to find out what the altitudes are that are involved there. Now, the next thing we should be concerned with as we're getting prepared for this approach is an approach checklist. Now, I'm not talking about the checklist for your aircraft. That's for granted. But you should have an instrument approach checklist. It does a couple of things for you. One, it helps spread the workload out from the time you first pick up the ATIS until you're on the final approach.
Now, this looks like the thing that you used on departure.
Yes. I use one for departure and one for the approach. And they also help me locate the charts when I need them in a hurry. Many pilots will let themselves coast until the very last minute. They're ready to intercept the localizer, and now they find they've got a whole lot of things to do, tuning in facilities, identifying them, and they're just too busy. This spreads the workload out, so it makes it comfortable. And the other thing it does is it assures you don't forget something important. So use a checklist. Everybody ought to use a checklist because we're all fallible in that way. Now, it's a VFR day, and we're going to be talking to the approach controller. We can expect him to say under those conditions, to call us and say, Baron 541, expect a visual approach to runway 24. Jack, I suggest that you file IFR whenever practical and fly the published approaches all the way down to help accelerate your regaining your IFR skills. Remember, the ability to fly safely on instruments in bad weather is a use it or lose it skill. You remember the little R that was up in the communications box indicating that we would receive a radar vector. And whenever you see that, you can expect that they will turn you in high and close in.
It's happened to me, yeah.
Yeah, so we want to take control here. Remember that the controller down there, he's not a relative of God. He's your employee. Okay. And so ask him to work for you. Ask him for what you want to do, and you'll be surprised how cooperative they are whenever they can be. So in this case, to avoid that high close-in turn, which raises the pucker factor to the nth degree, you can ask for the published approach with the transition. In this case, the homily transition. Or if you're coming in from some other direction or from on an approach that doesn't have a transition, you can ask to be turned on at a point that both you and the controller recognize, such as the Escondido beacon or the Theno intersection, something like this. If none of those exist, then ask to be turned on 1 mile outside the gate. Now, the gate is described as being 1 mile outside the final approach fix, or 5 miles from the end of the runway, whichever is furthest. Now, this is going to give you an intermediate segment to allow you to get squared away and make a proper approach. Also, allow your autopilot to be capable of latching onto the glide slope. Now, speaking of autopilots, many pilots that I've talked to seem to be afraid to let the autopilot make the approach when the weather's bad. But you know, that's exactly when you should let the autopilot make the approach. And one reason for it is the autopilot recognizes excursions in milliamps, where the human pilot is constantly herding the needles back into the middle because they're moving out and he has to herd them back in, and they sometimes move quite far. If you have an autopilot you can trust, let the autopilot make the approach when the weather's lousy, and you can keep your hand in by making those approaches when the weather is VFR or fairly good condition. So when you if you're going to make an autopilot approach, though, when you first talk to the controller, tell him this will be a coupled approach. And the reason you want to do that is, in many cases, there's a perimeter road around the approach end of the runway, and there'll be trucks running back and forth, or aircraft may taxi up fairly close. This can cause a glitch in the glide slope. Have you ever noticed that when an aircraft flies over and you're watching your TV and the picture begins to flip?
Yeah.
That's a reflection off the metal object that's, in this case, the airplane.
Oh, I see.
And the same thing happens here. The signal can bounce off of an aircraft or a truck and intermingle with the main signal, and you'll get quite a large excursion on your glide slope. If you're coupled, the autopilot will try to follow that. And especially if it tries to follow it down abruptly, it can be quite hairy that close to the ground. Mm-hmm. Now, if the ceiling is lower than 800 feet, or the visibility less than 2 miles, the controller will protect against that sort of thing happening. So be sure and tell him that when you're on a coupled approach. One more thing. I've had people tell me that their autopilot just doesn't work well on an ILS. What they haven't taken into consideration is the requirements that the autopilot must meet in order to latch onto the glide slope. And in many cases, those requirements are similar to this. The localizer must be captured, the aircraft must be below the glide slope, and the altitude hold function in the on position, and all of these must exist for about 20 seconds prior to reaching the glide slope. So, Jack, check your user's manual for your autopilot to see what the requirements are for that particular autopilot.
I certainly will, Tony.
You know, a good instrument pilot, Jack, only has to remember 2 things.
Now wait, you told me what they were. Those are the next 2 things.
Yes, the next 2 things. And as you accomplish those, just think of the next things, then the next thing. What I'm saying is stay ahead of the aircraft. Mm-hmm. Now, a good instrument pilot also has to be able to visualize. I've seen people get lost in a holding pattern and didn't know where they were. Similar to when you're driving home at night, the road you've driven for many, many years, you're thinking of something else and you look around and you don't know where you are. You must be able to visualize, know where you are at all times while flying the instruments. Another good way to visualize is to fly a ghost ship just about 3 miles ahead of where your ship is. And think about what it is doing. If it's slowing down, that's what you have to prepare to do. If it's making a turn at an intersection, you have to prepare to do that. Visualization, very important to a good instrument pilot. Okay, let's assume now that San Diego clears us to 5,000 feet and instructs us to turn to 090 degrees after passing the Oceanside VOR for vectors to the ILS approach at runway 24 at Palomar. Mm-hmm. Right away, we can be pretty sure this will be one of those high close-in approaches. So here we will request the published approach with the Homley transition. And like I said, ATC will be cooperative whenever they can, so he will clear you for the published approach. So when he does that, then instead of turning to 090 degrees, we will follow the 083 radial after passing Oceanside, mm-hmm. but we'll stay at 5,000 feet until we're cleared for the approach or receive a lower altitude. Notice, Jack, that on the approach plate it says that radar or ADF is required for the approach. Now, of course, that doesn't mean you must have radar in your aircraft, but the radar at the approach control facility must be operational, or you must have an ADF equipment in your aircraft. Mm-hmm. Now, if you have a rotatable card on your ADF, rotate it so that it always matches the heading you're flying. That way you don't have to figure relative bearings. For instance, when you reach Homley, the head of the needle will read 195. No figuring to it. Now, let's talk about identifying the ILS. If you're on the initial segment, don't be surprised if you tune in the #1 nav on the ILS and you're not able to identify the ILS at that time. In the old days, there used to be what we called a clearance frequency that surrounded the ILS station, and no matter where you were, you could get the identifier and the needle would peg itself on one side or the other, the yellow or the blue sector. At some point, they put in new ILS systems and that particular feature was omitted. So you might find while you're on the downwind here or on the initial segment that you'll get what we might call glitches, and the ILS needle's liable to bounce back and forth from one side to the other. As you can see from this drawing, Jack, you can only get a really good signal from this ILS if you're within 35 degrees either side of the center line within a 10-mile arc, or if you're within between 18 miles and 10 miles, a 10-degree radial from the center line.
I would think that that would just like fan out evenly.
Well, it does, but the signal that's out here near the 35-degree angle weakens quite rapidly as you go out. The strong signal is just down the center line. So if you're 18 miles out, you have to be almost lined up with the center line to get a good signal. This also means that if you're on the initial approach segment over here, and you have an autopilot that you can arm the ILS, if you arm it back in that area and the needle zigzags once or twice, the autopilot might latch onto it and start taking you off cross-country someplace. So watch for that.
Okay.
Okay, now you got to remember too that once you're on this ILS, that the needle sensitivity is going to be 4 times the sensitivity that you would find on a VOR. So you're going to have to fly it much more closely, and when we get into the simulator, I'll show you how that can be done. You know that some of the ILS localizers are much narrower than others.
Oh, I didn't know that.
Yeah, some can be as much as 6 degrees and others as little as 3 degrees.
Seems like all that I've flown have been very narrow.
Yes, but it's all based on this fact. The ILS and localizer antenna is at the far end of the runway. What they try to do is have the width of the localizer exactly 700 feet as it crosses the approach threshold. So you can see that if it's a long runway, say 12,000 feet, and it's 700 feet wide at the threshold, it's going to be a very narrow beam. Now, if it's a 5,000-foot runway and it's still 700 feet wide at the threshold, it's going to be a much wider beam. But it varies between 6 and 3 degrees anyway.
Okay.
Incidentally, all back courses are narrower than front courses.
Why is that?
Well, you got to remember where the antenna is located at the far end. And so instead of being 700 feet wide as you approach it from that direction, it's only a few feet wide. That 700 feet will be way back down there, maybe half a mile or more on the approach. So they're much more narrow and therefore much more difficult to fly.
I know they're more difficult to fly. I just never knew why. I'm learning a lot of things here.
Well, of course, they raise the minimums so that you're not so much in danger of running into the ground. Now, let's talk a little bit about the components of an ILS system. There are 5 components. There's the localizer, the glide slope, the outer marker, the middle marker, and the approach lights. And if any one of these is not operating, then probably the minimums will be raised. And of course, JEP shows you that at the bottom of the chart here, and NOS has a separate plate for that in the book to show you how much they do raise the minimums if any of these components are not operating. Okay, now what we would probably do on this initial segment here is set the number 2 nav on Oceanside and fly that on the initial segment while we're setting up the number 1 on the ILS itself and identifying it and getting everything done that we can, setting the inbound heading and all the rest of it. Now, some ILSs, Jack, have DME associated with the ILS. In the service, we used to call those ILSTACs, ILS TACANs. As an example, Montgomery Field. And you'll notice that that information is in the ILS box on the approach plate, where it gives the frequency and the inbound heading. It'll say DME ILS. Now, since the DME is not mentioned up here in the right-hand corner of the chart, you don't have to have DME to make that approach. Just that you're not going to get the DME information, of course, but you can make the approach down to the prescribed minimums. Now, in a case where there is no DME associated with the approach, maybe there's something else that you can do. Let's take a look at the Carlsbad approach here, for instance. We could learn from looking at the VOR approach that the VOR is 9.6 miles from the airport. Okay? So when we're coming in on the final approach, if we have the DME information working for us, that is, we have the DME on number 2 nav or on hold, then we can just subtract mentally 9.6 miles from what we're reading, and that's about how far we are from the airport. Now, it won't be exact because there's a slant distance, but it's useful information, and we should use all the information we can.
Certainly, yeah.
Incidentally, in some cases, the number, the RNAV, and you have an RNAV,
Certainly.
is yours on your number 1 nav or your number 2?
It's on number 2.
Well, good, because in a case like this, you can use your number 1 to make the ILS and set the field information up, the RNAV information, on your number 2, and it's just about as good as having DME on the ILS itself. Some people have a switch where they can switch the RNAV back and forth between number 1 and number 2, and if you ever have that capability, be sure you have an annunciator light to tell you which nav the RNAV is on, because boy, can that be confusing when you when you're not sure.
Yeah. Mm-hmm.
Now, place the marker beacon in sensitivity switch in the low position. Remember, that's not a volume switch, it's merely a sensitivity switch. Put it in the low position so that the beam is as narrow as possible so you can locate the outer marker more accurately. Notice also, Jack, on the profile view, there is a note on pilot lighting. And you can turn the lights on at night by using the mic switch.
You're seeing more and more of that across the country, it seems.
Yes, you know, years ago when I was flying a small aircraft at night across the country, just to check on my navigation, I would pick up the mic and turn on the lights on a field and see where it was and where I was in relation to that field. But the altitude we're flying at these days, that doesn't work too well. Now, Jack, I would suggest you turn the lights on if this happened to be a night landing. Turn the lights on while you're on the initial segment. And turn them on to the brightest available lighting. Click it 7 times within 5 seconds, regardless of what the lighting capability is. Click it 7 times, and you'll get the brightest available lighting. Now, when you break out, if that's too bright, then pick up the mic or use your button on the wheel and click it again and set it at the brightness that is best for you. Now, Jack, if the lights are already on when you arrive, go ahead and click it 7 times anyway. You don't know how long ago they were turned on, and they're set for about 15 minutes, and they'll go off at the most crucial time during the approach.
Right.
So initiate it yourself. Now, Jack, note the minimums on the NDB approach. Now, this would be particularly important if the NDB was co-located with the outer marker. Mm-hmm. And take your pencil. I want you to notice the minimums and the missed approach. Now, the missed approach will generally be the same as the ILS because they end up at about the same place. So no problem with the missed approach, but the minimums are going to be different. Take your pencil and mark the minimums of the NDB on the ILS approach.
Why?
Well, if the glide slope goes out, well, you continue right on down to the localizer minimums, and you can still make the approach, right? But if the entire system goes out, you're without anything at all. You have to go back and start over again, and if the only approach left to get in there is the NDB, you've got to start from scratch. You'll never be in better shape to make that NDB approach than you are right now if you've planned ahead, because the localizer has you right smack on the middle of it, right in the middle of the runway. So hold the heading as tight as you can, and just come on down to the NDB minimums, and level off, fly the MDA. If you see the field, come in and land. If you don't, and you have to make the missed approach, there's no point in going back and making that NDB approach again because you probably couldn't do it as well as you did that time.
That also is predicated on me having a good time fix, too, when I was on that glide slope.
That's correct. So another good reason to take a time fix even though you're shooting the ILS. It's good practice. Just punch the clock and start it running. Most time you don't need it, but if you need it, it's there. Now, on this approach, you can keep your speed up on the initial segment until you're about 12 miles out away from Oceanside, and then begin to slow down as you're approaching Homley. Now, at some point along here, we'll either be cleared for the approach or cleared down to 4,000 feet. In order to make that descent, remember, any given configuration that you happen to be in, reducing 1 inch of manifold pressure will give you approximately 100 feet per minute rate of descent for that configuration. Mm-hmm. So let's reduce from 17 to 12 inches. The aircraft will stay at 120, and you'll have about 500 feet per minute rate of descent. So we're approaching Homley now, and we can expect to be cleared for the approach. When we're cleared for the approach, we are cleared all the way to the missed approach facility, not to the airport or middle marker or anything like that. because if you do have to make the missed approach, there wouldn't be time for the controller to clear that area for you. So in this case, we're cleared all the way to the oceanside VOR to hold at 3,000 feet. Now, when we get to Homley, we're going to make a descending right turn and level off at 3,400 feet. Now, although the 195-degree segment of the initial approach is indicated as a flyable route, the aircraft will be in a constant turn, so you will never level off, straighten out on 195. So from the Homley intersection till you're near the Escondido beacon, you'll be in a constant descending turn. Just fly the head of the ADF needle and level off at 3,400 feet. Bring in 17 inches again, and you're now on the intermediate segment of the approach. Remember, too, that the last heading that the controller gives you after he's given you clearance for the approach, and he gives you a heading to intercept the localizer, that's advisory only. Oh. Mm-hmm. So if it doesn't look good to you, take another heading. This may be particularly true where there is a locator auto marker, and you can see from your ADF needle that you're going to intercept inside the auto marker. Well, you certainly don't want to do that. So take a heading that will put you on the localizer outside the auto marker. As the CDI begins to center, follow the CDI. You're now in level flight with 17 inches of mercury, 3,400 feet. Get stabilized now, and this means getting the aircraft ready for the approach. Get the proper speed, have the proper power setting. You're in the proper configuration. That is, at this point you have the gear up and approach flaps. And most important of all for a good approach is trim. If you're going to hand fly it, make sure that you trim the aircraft constantly, and so you don't have to overcome any pressures. The speed on the final approach, as I say, should be 120, but in all cases it should be somewhere above the blue line for safety. Let me say just a little bit now about the glide slope intercept altitude. And that's the 2,300 feet that you see here that intercepts the glide slope. It has no particular meaning. I mean, you might intercept the glide slope back here at 3,400 feet at the NDB beacon, and you're on the final. However, it does have a meaning to the people who fly for hire. You see, their regulations state that if they're outside of the final approach fix and the field goes below minimums, they're not allowed to come down and take a peek. But if they have passed the final approach fix, it's okay to come down and take a peek. Well, maybe we should, again, use the same rules that they use, because after all, they're getting instrument checks every 6 months, and we probably aren't. How does it apply then to the ILS? Well, the glide slope intercept altitude becomes comparable to the final approach fix for the non-precision approach. So if you've intercepted the glide slope at 3,400 feet and you're coming down and the field goes below minimums before you pass 2,300 feet, under those rules, you shouldn't come down.
Under the airline rules, yeah.
Yes, then you shouldn't come down and take a peek. But if you're below 2,300 feet, well, they say it's okay to come down and take a peek. That's up to you whether you want to accept those rules or not. Mm-hmm. When you intercept the glide slope, that is your final approach fix for the ILS. And the action that you take there is to drop the gear. This will normally just naturally put you on the rate of descent that will keep you on the glide slope. Now, Jack, if a problem develops anywhere along while you're on the final approach, you must make a missed approach. But you can only make the missed approach safely from the missed approach point, and that would be near where the decision height is on an ILS approach. For instance, if an immediate turn is required back to a facility such as a VOR for the missed approach, you can only make that turn from the missed approach point. Don't make it early. You might not have the clearance that's required, and it may be a dangerous thing to do. You may, however, begin climbing immediately to the assigned altitude. Jack, I suggest we go into the simulator now, and I'll try to demonstrate an ILS approach for you.
Good, I'm looking forward to seeing that.
Good. You know, Jack, after only 3 or 4 attempts, many pilots can execute an ATP quality ILS approach using the procedures that we will explain on this approach. Now, we've passed the Homley intersection, and we've leveled at 3,400 feet. Now, we're still on the initial segment. Okay, the localizer is alive. Now as we turn to intercept the localizer, if we keep the tip of the lubber line on the tip of the CDI, we will automatically compensate for any crosswind. We'll just bring them in together. Now this way we won't drift off the localizer and then have to correct back. Place the bug on the runway heading and then keep the lubber line within the confines of the bug. Initially, we will assume a no-wind condition. However, it appears we have a crosswind. So we'll move the bug one bug width in the direction of the wind, and now again we will keep the lubber line on the bug. That is, we'll make corrections no more than 5 degrees in either direction to keep the CDI centered. Okay, the glide slope is coming down. It's almost centered, and we'll lower the gear. Now with the gear down, it will create enough drag to cause the airplane to go into the almost proper rate of descent without touching the power, and the airspeed will stay the same. Now by staying on the bug, we avoid this kind of zigzag down the final, performing unusual maneuvers all the way down. Notice, Jack, that the rate of descent for this approach is 688 feet per minute with no wind condition, and using 120 knots, which is our chosen speed. Now, if we look at our rate of descent and we find it's fairly close to 688 feet per minute, then there's no problem. But if we find that we have, say, 400 feet per minute and it's stabilized, there may be something wrong here that we should be aware of. For instance, right now we ought to get a wind check and see what the surface wind is. Because if you take a look at the bottom of your chart, you'll find that 400 feet per minute, it corresponds to 70 knots ground speed, but we're indicating 120 knots. Now we have 50 knots that we have to account for. We should get a wind check right away, and if the wind on the surface is light, then we can expect a wind shear on the way down. However, if we've got a 30 or 40 knot wind on the surface, then there's nothing to worry about. Everything is as should be. But always check, always get a wind check as soon as you're turned over to the tower. Now there's another way of checking this, Jack. Some ILSs have a DME associated with them, so don't forget to turn the DME on to the ILS when you join. And once again, if the DME ground speed is, for instance, 70 knots, we have the same situation that we just explained. And we must get a ground surface check on the wind and find out whether there will be a wind shear or whether we can expect a wind shear on the way down to the runway. At least this way you have some advance warning that there might be a wind shear situation. Okay, we're descending properly now, Jack. And let's talk a bit about scan. Let's look at only the instruments that are giving us the information that we really need. The artificial horizon, of course, is primary. We always come back to the artificial horizon and then look at other instruments. The HSI and the CDI and the navigation information that's on the CDI is very important. So we're going to scanning up and down between and try to do it quickly. Now we'll change the bug whenever necessary to take care of the changing wind on the way down. Another instrument that is quite important is the airspeed. So we'll glance over at the airspeed. We're just outside the outer marker now. And as we come down through the outer marker, and there it is, you can hear it now, we should check our altimeter. We should read very close to 2106 as we go through the middle of the beacon. And if we don't, we should get an altimeter check because we don't want to descend all the way to minimums with the wrong altimeter setting. Okay, now get information as you come down one piece at a time and then right back on the gauges again. Now, Jack, about 500 feet above the decision height, we should start calling altitudes out to ourselves. Like right here now, we're at 400 feet above minimums, and we should call it out every 100 feet. We're now 300 feet above minimums. This keeps us aware that we're getting closer and closer to the minimums where a decision has to be made. The localizer and glide slope are getting harder and harder to fly because they're getting narrower. We have to be more and more careful. We're 100 200 feet above minimums now, descending. As we approach 100 feet above minimums, we'll call approaching minimums and be ready to make the missed approach in case we don't see the runway environment. If we see runway environment, we'll put flaps down, ease the power back, and we should always know what kind of approach lights to expect. So take a look at those before we make the approach. Pilots have lined up with bridges and highways when the visibility was poor, so know what to expect when you break out. Now slow the airspeed, reduce the power, and the airspeed will be reduced from 120 to approach speed as you cross the threshold. Notice the runway threshold crossing height on the chart and try to cross close to that height. Now try to make each and every approach exactly the same. Cross the threshold at the same height, transiting the same speed. In your case, Jack, about 95 would be a good speed to be transiting just as you cross the threshold. Then keep the nose coming up and the power coming off, and the aircraft should pay off right near the instrument touchdown zone. Now, Jack, the ILS decision height may be before, at, or after the middle marker. Now, in this case, it's after the middle marker. The middle marker is ideally placed at 3,500 feet from the end of the runway, but obstacles often prevent exact placement. The missed approach point on an ILS is the decision height. Remember, the pilot cannot fly this altitude looking for the runway, and he cannot go below this altitude unless the runway environment is in sight. If the runway is not seen, the pilot must immediately execute a missed approach. Now, you only need to remember two things about the missed approach, no matter how complex: the initial altitude and the initial heading. If you must, you can read the additional instructions after the aircraft is safely on the missed approach track. If the initial portion is straight out, fly the bug because you've already compensated for the wind. If you make a missed approach, Jack, be ready to answer the inevitable question: what are your intentions? Now, any action is available to you. You can make another approach, you can hold for better weather, or you can hold to check weather at nearby airports. You can return to the departure airport, or you can go to your alternate airport. But remember, the alternate is only mandatory if communications is lost. Let's summarize the approach procedures, Jack. First, you must study the approach plate thoroughly. Have a working knowledge of associated approaches and the alternate airport approaches. You must complete all required checklists, both those for the aircraft and those for the approach. Get the latest weather just before initiating the approach. After identifying a nav aid, turn the volume down, but listen for the identifier. If it should quit, even though no flags appear, abandon the approach and investigate. Use all of your navigational equipment to help make a safe approach. Don't leave the number 2 nav, for instance, on some facility 20 miles down the road. Back up the primary if nothing else. And don't chase needles. Learn to scan only those instruments that are supplying useful information. Now, don't duck under the glide slope when you break out. Keep a constant rate of descent to your normal flare point. Now, don't let pride prevent you from initiating a missed approach if any doubt exists as to the safety of the aircraft. Mentally prepare for the possibility of missing the approach just as you prepared for an abort on the takeoff. And don't descend below the decision height or the MDA unless the runway environment is definitely in sight and you are in a position to make a safe landing. You don't have to prove anything to anybody. When in doubt, when spatial disorientation or vertigo try to fool your senses as a mirage in the desert, have faith in your instruments. Apply all of the safety tips found in most aircraft owners' manuals. Get an occasional checkup with a qualified instructor. But most of all, take your instrument flying seriously. You will find a sense of accomplishment and pride in knowing that you have completed an instrument flight safely and in a professional manner.